Learning how to use modules is an essential part of being able to learn how to use Python. Any Python file ending in .py can be used as a Python module. You will also sometimes find modules that are compiled into .pyc or .pyo files as well. In this example, I have a prepared import_demo.py file that demonstrates multiple methods to import modules and/or their data attributes and functions. The most basic form of an import is to use import the name of the module. And then you'll be able to use data attributes like math.py or math.tan parenthesis some value parenthesis to access either a data attribute of that math module or a tangent function of that math module. What we'll see in all the examples is the use of dir, which will print a list of names in a particular namespace. If you don't specify the namespace, it defaults to _main, the normal default main namespace. I'm going to go ahead and run this module. We'll see what happens with this very first block of code. And we see the list of object names in that main namespace. And then the printout of dir parenthesis parenthesis. And then what happens to the main namespace after import math has been executed. You'd notice that math is an additional name in the main namespace. And it attempts to access math.py or math.tan parenthesis some value parenthesis were successful. Going back to the example, after printing out the value of pi and the tangent of 1, the math name is deleted from the main namespace. And then the list of object names in the main namespace will be printed out again. In the second example, the name of math is alias to a name of fun. So we will import the math module as fun. And when we look at the namespace, it's going to have fun in it instead of math. And we'll access attributes like fun.py and fun.tan parenthesis 1 parenthesis to use that data attribute or call that function. And you can see deleting that fun name once it's completed. So going back to the shell, right after the first one executed, we see the second list of names, again, back to the normal default, where the fun name was added to the list of names, and that it was successful in accessing pi and the tangent functions. A third way of working with names is to import selectively things like data attributes or function names directly into the main namespace. In this example, from the math module, it's importing the pi data attribute and the tan function. So you'll see in the output from the shell that these names are added to the main namespace, and then they don't have to be prefixed with that namespace of math or fun. They can just be used directly, like pi and tan. So if we look at that output, we do see pi and tan directly in the main namespace, and that accessing that attribute or calling that function was successful. Now, to avoid conflict with names that you might already have defined in your main namespace, you can use aliases. Like we did before for the entire module, you can also do this selectively with aliases for things brought into your main namespace. So the next example here is from math. Import pi as pi with an E, tan as tangent spelled out, and then those names, pi with an E and tangent all spelled out, would be able to be used directly in your program code to either access that attribute or call that function. And so we can see that back in the listing of the namespaces, how pi with an E and tangent spelled out appeared and functioned just fine. Now there's one more way that sometimes you see people do, and that is to use a wildcard. In this last example, it's from the math module import asterisk, which pollutes, as they say, a namespace. Every name that was defined within that math module will now appear within the main namespace. So you see that long listing of all those different things, tan and pi, amongst many, many others. And particularly if you did not author that module, it's not a good idea to import with a wildcard, not knowing how those names could actually end up overwriting names that you had already defined. So you should avoid using the wildcard import, unless you might be experimenting in your shell. So now that you've seen different ways of doing imports of modules, their data attributes, and their functions, let's create a module of our own that will import something from a module and then use it to perform some calculations. Let's go to File, New File to go create that code. We'll take advantage of pi from the math module. Now, since pi is not likely to be defined in our main namespace, and it's the only thing we're going to need in this example, we might just start off with from math import pi. We will use again the input function that was previously discussed to obtain some information from our user. We'll get the radius of our circle by prompting the user with input function and a string prompt such as what is the circle radius, question mark, add that space, close your quote, close your parenthesis. Now the result of that input will be a string in radius. We'll need to convert that to a floating point number in order to do some of the calculations. But we will print and the first value will be the area of the circle is, and the second value will be our calculation. We'll use the float function, which is built into Python, to convert that radius to a floating point number. Pi r squared is the area of the circle. So the float of the radius squared, raised to the second power there, times pi. So that's radius squared times pi. We could also print the circumference. Using the same technique where 2 times the radius converted to a floating point number times pi will give us that value. Before we can execute this, we need to save this file. We'll put that in a folder like My Scripts, and we might call this Circle Demo .py. Click Save, and now go to Run Module or press F5. We get prompted for our circle radius. I'll say 5, or type that and press Enter. And you can see that it calculated the area and the circumference of the circle and printed those values. Once again, here's what our circle demo program looked like. We demonstrated importing a data attribute from a module, and then we used that name that we imported in doing our calculations.